Let's dive into the fascinating world of alarm clocks and unveil the secrets behind their ticking mechanics. To alarm clocks. At the core of an alarm clock lies its intricate mechanical system, consisting of gears, springs, and an escapement mechanism. These components work in harmony to keep time accurately. Gears in an alarm clock are essential for regulating the movement of the hands. They ensure that the second hand completes a full revolution every 60 seconds. Springs provide the necessary energy to power the clock. The main spring drives the timekeeping mechanism, while a separate spring powers the alarm. The escapement mechanism in a clock acts like a brake, regulating the release of energy from the spring, allowing for precise timekeeping. When the set time is reached, the bell ringer is activated, producing the familiar alarm sound to wake you up. To set the alarm, you adjust a dial connected to the alarm spring, aligning it with the desired wake-up time. The components of an alarm clock work together seamlessly. Gears regulate movement, springs provide power, escapement controls energy flow, bell ringer produces sound. Alarm clocks are not just timekeepers, they're essential tools that help us manage our daily schedules. If you're finding this exploration intriguing, a quick like would be amazing. The heart of timekeeping, gears and springs. Mechanical alarm clocks have captivated us for decades, using gears and springs to keep time. This intricate dance of components forms the heart of timekeeping, ensuring precision in every tick and tock. Gears are essential in an alarm clock, transferring energy from the mainspring to the hands. Each gear's size and teeth count determine the clock's accuracy, converting the spring's potential energy into motion. The mainspring is a tightly coiled strip of metal, storing potential energy when wound. This energy is gradually released, powering the gears and ultimately moving the clock hands. The escapement is crucial for time regulation, allowing the gears to advance incrementally. It releases energy in controlled bursts, akin to a heartbeat, ensuring steady movement and accurate timekeeping. The balance wheel and its spring, often found in place of a pendulum, oscillate back and forth. This oscillation stabilizes the timekeeping mechanism, akin to a conductor leading an orchestra. Separate from the mainspring, the alarm spring powers its own gear train and escapement. This allows the alarm to function independently, ensuring you wake up right on time. Synchronizing the time and alarm functions requires precise engineering. The timekeeping gears advance the hands. The alarm gears engage at the set time. Both systems rely on finely tuned escapements. Every tick and tock is a testament to mechanical precision. Understanding these components enhances our appreciation for the artistry in engineering. If you're enjoying this exploration, consider subscribing for more insights. In harmony, gears and springs transform potential energy into precise movements. This symphony of components keeps time ticking, blending functionality with elegance. What are your thoughts on this mechanical marvel? Let me know below. Understanding the gear train. At the core of a mechanical alarm clock lies the gear train, a series of gears that transmit power and control the movement of the clock hands. This intricate system ensures precision in timekeeping, making it essential for the clock's functionality. In a clock, different gears serve specific functions. The main gear powers the clock. The escapement gear controls the release of energy. The alarm gear triggers the bell ringer. The escapement mechanism regulates the release of energy from the gears, ensuring the clock hands move at a consistent pace. It acts like a brake, controlling the gear train's motion with precise timing. Energy from the clock's main spring is transferred through the gear train, powering the clock's hands. This transfer is crucial for maintaining the clock's accuracy and ensuring the alarm sounds at the right time. The mainspring stores potential energy that powers the gear train. As it unwinds, it releases energy, driving the gears and ultimately keeping the clock ticking. The gear train synchronizes the movements of the hour, minute, and second hands. Each gear is carefully calibrated to ensure the hands move in harmony, providing accurate time display. The alarm function has its own dedicated gear train. When the set time is reached, this gear train activates the bell ringer, alerting you with sound. It's an ingenious use of mechanical motion. Every component in the gear train is meticulously designed to ensure precision. From the smallest cog to the largest gear, each part plays a vital role in maintaining the clock's accuracy. If you're enjoying this insight, consider subscribing for more. Powering the clock, the role of springs. At the core of a traditional alarm clock lies the mainspring, a tightly wound coil of metal that stores potential energy. This spring is crucial as it gradually unwinds, releasing energy that powers the clock's gears and ultimately keeps time. Springs store energy through tension. When wound tightly, they hold potential energy, which is slowly released as the spring unwinds. This conversion from potential to kinetic energy is what drives the clock's mechanisms. The energy released by the mainspring is transferred to a series of gears known as the gear train. This train of gears is meticulously designed to control the speed and movement of the clock hands, ensuring accurate timekeeping. An alarm clock typically contains a separate spring for the alarm function. This spring is wound when the alarm is set, storing energy to activate the bell ringer at the designated time. The balance wheel and its spring work together to regulate the clock's ticking. The oscillation of the balance wheel ensures that the energy from the mainspring is released in a controlled manner, maintaining consistent time intervals. An escapement mechanism works in tandem with the balance wheel, controlling the release of energy from the mainspring. It ensures that the gear train advances in precise increments, allowing for accurate timekeeping. If you're finding this useful, a quick like would be amazing. Regular winding of the mainspring is necessary to maintain tension and ensure the clock functions correctly. Without it, the spring would fully unwind, halting the clock's operation. Mechanical alarm clocks are a marvel of engineering, where springs play a pivotal role. Their simple yet effective design has stood the test of time, captivating those who appreciate the intricacies of traditional timekeeping. What are your thoughts on this? Let me know below. The bell ringer mechanism. The bell ringer mechanism is a fascinating part of a mechanical alarm clock. It transforms the clock's energy into sound, alerting us when it's time to wake up. Let's explore how this intricate component works. The bell ringer mechanism consists of several key components that work together to produce sound. The hammer, which strikes the bell itself, which resonates the sound, the gear train, which powers the hammer. The hammer is a small but crucial part of the bell ringer. Powered by the clock's gears, it repeatedly strikes the bell, creating a ringing sound that wakes sleepers. The bell is designed to amplify the sound produced by the hammer. Its shape and material are optimized to create a loud, clear ring that can be heard across the room. The gear train is the powerhouse of the bell ringer mechanism. It transfers energy from the clock's main spring to the hammer, ensuring the bell rings at the set time. The bell ringer is precisely synchronized with the clock's timekeeping mechanism. When the alarm time is reached, the gear train engages the hammer to start ringing the bell. Setting the alarm involves adjusting the clock's gears to ensure the bell rings at the desired time. This manual process requires precision, but offers reliability. Regular maintenance is essential to keep the bell ringer functioning correctly. Dust and wear can impede the gears and hammer, reducing the effectiveness of the alarm. The bell ringer mechanism is a testament to the ingenuity of mechanical design. Despite modern alternatives, its simplicity and reliability keep it in use today. If you're enjoying this exploration, consider subscribing for more insights. Synchronization, how components work together. At the core of a mechanical alarm clock is the escapement mechanism, which regulates the clock's ticking. This delicate balance of gears ensures the clock's hands move at a consistent pace, translating the energy from the mainspring into steady timekeeping. The mainspring is the powerhouse of the clock. When wound, it stores energy that gradually unwinds, driving the gear train and keeping the clock hands moving. This energy transfer is the backbone of the clock's operation. The gear train acts as a transmission network, converting the energy from the mainspring into rotational movement. Each gear is meticulously sized to ensure precise timekeeping, working in harmony to drive the clock hands. The balance wheel acts like the pendulum in a grandfather clock. It oscillates back and forth, regulating the release of energy from the mainspring through the escapement. This ensures the clock ticks at a steady rhythm. Setting an alarm involves winding a separate spring that powers the alarm mechanism. When the set time is reached, this spring releases, engaging another gear train that triggers the bell ringer to sound the alarm. The bell ringer is activated by the alarm's gear train, striking a bell or buzzer to produce sound. Its timing and intensity are finely tuned to ensure the alarm is both audible and punctual. Precision in a mechanical clock is achieved through meticulous engineering. Each component's design and placement are crucial for accurate timekeeping, ensuring that all parts work in concert to maintain reliability. In a well-tuned alarm clock, all components must work in perfect harmony. From the escapement to the bell ringer, every piece plays a crucial role in the symphony of timekeeping. If you're enjoying this deep dive, consider subscribing for more. Troubleshooting common issues. If your clock isn't keeping time accurately, the issue might lie with the oscillating wheel or the main spring. Ensure that these components are wound correctly and are free of dust or debris that could impede their motion. When an alarm doesn't ring, consider these factors. Check if the alarm spring is wound tightly. Inspect the bell ringer for obstructions. Ensure the alarm is set correctly and is not in silent mode. If the clock hands are stuck, you may need to realign them. Gently adjust the hands to ensure they are not touching each other or the clock face, which could prevent movement. A sudden stop might be due to a lack of lubrication. Regularly applying clock oil to the gears and springs can help maintain smooth operation and prevent unexpected stoppages. For winding mechanism problems, try the following. Check for broken or worn-out winding keys. Ensure the mechanism is free from dust and debris. Verify that the springs are not overly tight or loose. Loose or missing screws can destabilize your alarm clock's components. Regularly check and tighten screws to ensure all parts remain securely in place, preventing misalignment or detachment. For digital clocks, ensure the power source is stable. Check the power cord for wear and ensure batteries, if used, are fresh. Faulty connections can lead to erratic behavior or complete failure. Regular maintenance is key to preventing issues. Clean your clock periodically, lubricate moving parts, and inspect for wear. This proactive care extends the life of your clock and ensures reliable performance.